Hi everybody. Welcome to my presentation entitled Artificial Intelligence and Foreign Language Learning, presented August 5th, 2016 at the International Conference on Social Sciences, Arts, Economy, and Education in San Francisco. My name is Jan Stewart. I'm from Chikushi Jogakuin University in Dazaifu, Japan. Artificial intelligence is defined as the intelligence exhibited by computers, either in the form of hardware or software. The term was first used by John McCarthy in a proposal for the Dartmouth Conference on Computer Intelligence to be held in 1956. Though my presentation is mostly philosophical, I'll begin with a few practical applications of computers in the field of foreign language instruction. I'll begin with computer-assisted language learning, abbreviated as CALL, and this has a recent history, as you can see on your screen. However, the use of artificial intelligence has a natural enemy, the human, as seen in total physical response. Other questions arise, such as Krashen's left brain, right brain dichotomy, and whether it can be paralleled in the silicon world. This brings me to the philosophical portion of my presentation, in which I'll make frequent reference to the film 2001: A Space Odyssey. It's rather old, so I'll give a brief synopsis. The film begins with some ape-like creatures who encounter a strange monolith. This monolith affects evolution, and they become humans. Much later, the moonwalker meets the same monolith, which transitions to the Jupiter mission. Now here's the important part, because a computer named HAL, H-A-L, dominates the spacecraft. He controls it, but when he learns that the human members of the crew have human weaknesses, they threaten the mission, so he decides to exterminate them one by one. In this picture we see them discussing what to do, although he can read their lips. Finally, at the end, the one remaining human member again meets the monolith, which affects evolution and produces a new type of human being. During the course of the film, the author and director raise several philosophical questions. First, can computers think? And do computers have feelings? And my philosophical question is, how does artificial intelligence relate to foreign language learning? In 1950, Alan Turing proposed a philosophical proof that computers can think. In the Turing Test, he divided a room into two parts. On one side there was a human being. On the other side there was either a computer or a human being. If it was a computer, the computer's task was to convince the human on the other side of the divider that it was a human being. Now, how to pass the Turing Test? In this example, you see a sequence, 1, 2, 3, 4, 5, and question mark. Well, the obvious answer to this is R. But the answer is not so obvious. In a recent TV show in Japan, about 1/3 of the respondents could not answer this correctly, answering 6. And of course it depends on whether you come from a car driving culture or not. And even in a car driving culture, the automatic transmission has been taking over the manual transmission, so many people would not be able to answer this correctly. Now, in a more sophisticated version of how to pass the Turing Test, we have this instruction, which has many misspellings. In the following sentence, the correct answer is indicated by the capital letters. They spell out a word that rhymes with the correct answer. Ignore the literal content of the question and insert the number that sounds just like the word spelled out by the caps. What is the only answer to the following question? And you see the caps here are W-O-N. And a word that rhymes with W-O-N is 1. So 2 plus 2 equals 1. A derivative of the Turing Test is designed to tell computers and humans apart. The Turing Test was administered by humans targeting machines. The derivative test is administered by a machine targeting humans. And you see here the letters T, W, I, S, T, E, D, which we can read, but presumably a computer cannot. And you've all seen this type of question when you're trying to fill out an application online, and it wants to determine that you're not a robot. In 1980, the philosopher John Searle reversed the Turing Test, offering philosophical proof that machines could not think. In his Chinese room analogy, a computer sitting in the middle of the room would receive information from one person, and, searching through all the information in the world written in Chinese, find the correct answer and spit it back out the other side, convincing the person on the other side that it was a human being. However, this follows a stimulus, response, and reinforcement pattern, as you see in this example by Lao Tzu. If you see this shape followed by this shape followed by this shape, then produce this shape followed by this shape. Now in 2003, Umberto Eco suggested that computers be asked to do a back translation to verify the capacity to translate from one language into another. And here you see the same example. What brings happiness? Be the stream of the universe. Now I used a computer program to translate this from Chinese into English, and you see the back translation here. What a happy to go down. Now this depends on the definition of be the stream of the universe, whether it's imperative, you be the stream of the universe, indicative, it is the stream of the universe, or subjunctive, that it should be the stream of the universe. Now in the following slide it's sometimes simpler, such as in this French example, plus ça change, plus c'est la même chose, which translates, the more a thing changes, the more it's the same thing. And this back translation is exactly the same as in the original French. Now when it comes to the question, does a computer have feelings? We may ask, if so, what kind of feelings? How do these feelings relate to human emotions? Can a computer evoke feelings from humans? Well, we've all gotten angry at our computers at one point or another. But it's unlikely that a free-form Turing test of emotions could be produced. Imagine sitting in a room. A computer passes electronic messages that say, I love you, through a slot. How would you respond? With an E-Valentine? With a Dear Hal letter? There have been several attempts to define emotional intelligence. For example, in 1997, Daniel Goleman divided emotions into several different systems: social skills, self-awareness, self-regulation, motivation, and empathy. However, Joseph Ledoux divides it into multiple systems, which can be even further divided into numerous systems. And you can see he defines it here, the physiological components of emotion. Now at one point, he focused on fear, which you see here in the movie 2001: A Space Odyssey, when Dave was finally disassembling the components of the computer, and the computer responded, "Stop, Dave, I'm afraid." Now more recently, Martin Minsky, who was one of the original thinkers in the Dartmouth project, wondered if computers might have more memory, speed, or complexity to create emotions. Or are we giving them the wrong kinds of instruction sets? Is it because we only use zeros and ones? Or is it some magical attribute that humans possess that computers do not, which prevents them from having emotions? We need to find some way to resolve these issues, whether computers can think and whether computers have feelings. To this end, I will digress for a moment to take an example from the field of astrophysics. Now we have two completely opposite ways of thinking. There is quantum physics, which deals with flat space-time and only works well on a small scale. And there is general relativity, which deals with curved space-time and only works well on a large scale. Now, for a long time, the entire universe was thought to consist of matter and energy. But Jacob Bekenstein, in an article which deals with quantum physics and emails, came up with a new way of looking at things, in which matter and energy could both be described as information. A few years earlier, in 1997, Juan Maldacena had found that many equations used to understand the universe also worked in two dimensions, and this became known as the holographic principle. In my own Japanese room analogy, the dilemma between thinking and feeling is resolved in much the same way as the dilemma between matter and energy. Both can be described as information. Here you see the combatants on one side of the room who represent thinking, as in the Turing Test. The combatants on the other side of the room represent feeling, as in Hal's human-like response. The referee represents a set of rules, such as Chomsky's noun phrase and verb phrase rules, etc., or the myriad social rules which govern social interaction in Japan. But we also have the room itself, which is the man-made structure, open to permit a view of nature. This represents the nature-nurture argument, which is often heard in linguistics, contrasting the innate, or the nativist view, championed by Chomsky, or acquired through stimulus response and reinforcement, which is the behaviorist view, championed by Skinner. Now, in conclusion, let's return to the field of computers. During World War II, Alan Turing had worked with many of the leading British chess players in developing code-breaking methods. He also used chess as a platform for working out his early ideas on computers. Here is a game played in the movie 2001: A Space Odyssey. And you see how I've divided the words into game etiquette and game descriptors. The game descriptors are of the type that people used to use when they played chess games over the telephone and they could not see their opponent's chessboard. The game etiquette, as you can see here, makes it a more human-like interaction. And this implicitly leads to an answer to the question, how does artificial intelligence relate to foreign language learning? Should students imitate Hal in trying to learn a foreign language? By all means. What he has to say, how he says it, how he makes his audience believe he has feelings, his techniques of conversation management. These are quintessential examples of human verbal behavior. All offer viable models for foreign language students. Throughout 2001: A Space Odyssey, Hal gives an impressive example of artificial intelligence as analogous to foreign language learning. Granting an interview, extending birthday greetings, playing a game, asking someone's opinion, evaluating a situation, identifying a problem, denying a request, justifying unorthodox behavior, and protesting violation. In a sense, the entire film is an essay on what it means to be human. The monolith affects evolution. Moonwatcher discovers a tool, then uses his tool as a weapon. Hal uses both language and emotions as weapons. In the end, the monolith once again affects evolution. Starchild emerges as the next generation of thinking, feeling, speaking, advancing, no longer weapon-wielding, post-humans. Perhaps our language course levels should no longer be classified as beginner, intermediate, advanced, but rather thought, emotion, wisdom, thereby bringing language teaching methodology into the post-Hal computer age. And thank you for listening to my presentation.